Now it's time to move on to our next sponsored session from Snowflake, governing your data with Snowflake. We're going to be talking about turning the data swamp into a data lake. And I'd like to introduce Marko Slabak, who's a sales engineering officer for Snowflake. Marko.
Thanks, Lachlan. Hi, everyone. I'll just be sharing my screen now. Yes. Yep. So I appreciate everyone's time today. And yeah, I'll try and stick to about sort of finishing just before the 20 minutes to answer any questions. So I hope you enjoy some of the content coming up. So just a quick intro. My name is Marko Slabak. I'm a solution engineer here at Snowflake. And so today we really just want to talk about some of, what governance means from a Snowflake perspective, some of the initiatives that we're sort of implementing and features around that in terms of how you can bring governance policies to the platform, so how you can bridge that sort of technical implementation of what are otherwise, sort of verbal governance policies that go across the organization, and then how we can sort of get that to data engineers and apply them. And so just to do a quick intro for those of you who don't know what Snowflake, who we are and what we're about. So just to touch quickly, so Snowflake is a sort of what we call a global data network or data cloud. So we've sort of, we started off sort of as data warehousing as our bread and butter, but over time now we've evolved to a wider data cloud, right? We do a whole bunch of workloads, which we'll touch on in a few minutes. But also the idea is it's global. We are able to share data across clouds, across regions, really sort of stitch it together to the point where you can interact with organizations from other parts of, other parts of the planet without really having to deal with all the intricacies of it and so forth. And so next one. So if we look at some of the benefits, and I just want to touch on, obviously we're going to be zooming in on governance today, specifically around the areas of know your data, protect your data, unlock your data. But we'll also be looking from an access perspective and action. So by access, just quickly, just want to touch on that is, what we typically deal with is organizational data, and it's challenging just to master the data within your organization, being able to, break down or prevent data silos from emerging, which is, doesn't usually happen. They almost always emerge. But how can we, Snowflake, bridge all of that through data sharing, bringing everyone together through a common platform, all types of data together? But then also beyond that, like we talked about that global connectivity, right? So being able to then to extend to your ecosystem. And so you're no longer just having an inward view of your data, which, yields a whole benefit to itself. But you're also able to integrate with your ecosystem partners. So if you're a bank, you can better, work with regulatory authorities and so forth. If you're a retailer, you can work with marketing campaign partners, analytics partners, and so forth. And then you can even extend beyond that. So organizations typically not in your ecosystem who are in our third-party data, so in our, who are offering data sets in the Snowflake marketplace. So for instance, you might be looking at trying to better improve how you do, security analysis and threat detection on your logs for, say, cloud logs on AWS, Microsoft, Google Cloud. And you can work with partners. For instance, you can store that data in Snowflake. You can work with partners in the third-party app system to be able to analyze that data and tell you where there's holes, where incidents have occurred, etc. So you can really extend the traditional business data platform to areas where you normally wouldn't expect it to go. Secondly, on the action part, really that's where we focus on in Snowflake. It's all about getting output, and output that matters to the business. So being able to build data products, build data assets, get it to the front lines of the people who need them, and spending less time sort of focusing on how, building the engine and maintaining the engine, more so using the engine and running it. And so just quickly highlighted those, and now really want to start to dive into so governance after the next platform slide. And so at a high level, just quickly in Snowflake, we have sort of a requirements, so I like to call principles, just to touch on, the reason why we bring this up as well is that focusing on governance can get quite difficult, especially when you're sort of stuck in managing the data platform, and plenty of organizations get stuck in optimizing it, making sure just basic security is done, and managing files on a lake, all that kind of stuff. They get sort of bogged down with the details, and they got less, fewer people, less time to focus on locking down and matching governance requirements. So idea in Snowflake is we're pretty much as true SaaS as you can get for a data platform. So it's going to be fast out of the box. So you're doing less tinkering, doing optimization, building indexes, partition keys, collecting stats, all that stuff that we used to in the older world. The idea is it just works. So, right, it's up, it's running. We manage availability, we manage backups, like we said, manage performance, we manage the health of the system, minimize downtime, etc. So the idea is everything just works, and you focus on getting data in and business results out. And thirdly, like we talked about from the global Snowflake or data cloud, it's connected to what matters. So connecting all the various different domains internally, but also allowing them to connect to relevant ecosystem and third-party data partners as well, right? So they're creating one sort of huge virtual data layer that has no boundaries. And so under the hood, just quickly, so Snowflake, we were born and bred as a data warehouse, founded in 2012, and, sort of launched in GA in 2015. First few years focusing on that was our bread and butter, hardening that use case, doing it well, doing it at scale, battle hardened. And sort of over time, we learned to incorporate, obviously, the data lake workloads. And, that's sort of, I guess, where we differentiate too, rather than sort of seeing them as opposed views, lake having to destroy the warehouse as some relic or warehouse attacking the lake for being, unproven. The idea is, look, both of them can come together. They service different audiences, service different requirements, and really they're just part of one end-to-end flow at the end of the day. We can facilitate that through data engineering. So classic SQL, which, most of the technical world in the data space is used to, but we've also branched out to Java, Scala, and, Python will be coming soon as well. So being able to service, the non-SQL crowd, like data scientists, the younger group of data engineers who may not have come from a database background. It's a very inclusive platform in terms of the user base. And sort of all those combining together, obviously, to improve data science outcomes. Even now with some of the newest features in Snowflake, being able to deploy trained models inside Snowflake and score data as it lies, which is a huge advantage from a cost and latency perspective, and sort of keeping, and also from just a business perspective in terms of just keeping the data science teams close to the data engineering teams and close to business outcomes as well. And sort of to touch on the last two, once you need to sort of productionize all of this, so data applications, what we mean by that can be a broad area, is how you effectively, beyond just traditional BI and data science, how do you bring analytical data either internally, right? It might be custom front ends, custom apps. It might be for your support stuff to deal with customer complaints. It might be an engineer out in the field managing infrastructure, and they need to get some information about the assets and analytical attributes of it and so forth. So the idea is we can productionize a lot of outcomes from the BI and the data science world into these apps, right? And you sort of your requirements dictate where you need to build these apps. And then finally, data sharing, right? So we've already talked about that. That is a significant differentiator and investment, and that investment from our side in Snowflake. And so the idea is, look, we want to data share internally, externally, within the cloud, across cloud regions, across clouds, right? Sort of one global virtual network in that sense for data sharing. And so the way we do this is an elastic performance engine under the hood. Won't spend too much time on these, so we can move on to the governance piece. But the idea is, like we talked about, it's fast out of the box. Storage and compute are separate. Even compute is isolated from one another. So different domains and lines of business can have different compute, all operating on the same storage pool. Intelligent infrastructure. So like we say, SaaS, true SaaS, we manage everything, upgrades, health, backups, availability. So you focus less on platform management, and you can focus your teams on output, right? Going through engineering, warehouse, data science exercises to produce apps and output to share through data exchange, etc. And then lastly, SnowGrid, right? So this is sort of the underlying fabric that powers our global deployments. And that's really what enables data sharing, cross-cloud use cases, etc. And so we can take traditional data sources from the left and push it to the consumers on the right. We can scale rapidly for either side of the workload, and both if you've got lots of sources, lots of consumers. And we don't just do regular structured data, we do semi-structured data. We're moving to unstructured data as well now. So you can really, traditional productive use case in Snowflake is just throwing JSON data in, minimal data pipeline work, being able to just query it in place and performantly. And a lot of organizations get benefits out of that. So now, what about the governance? So if we look at the traditional challenges, data is everywhere. Managing data is unnecessarily complex. Security and governance are inherently rigid. These, probably aren't unknown challenges to people who are familiar with governance. So, in this event, and so I won't spend too much time on them. But really, when we want to dive in, data is everywhere, right? So tracking it is becoming problematic, especially as volumes grow. Event data comes in. Where is it going? What does it contain? What are the access patterns behind it? The complexity of the types, semi-structured, structured, unstructured, and so forth. So you're really wanting to understand as well how the data is being used, who is accessing it, what are the behavioral patterns behind it. Managing data unnecessarily complex, right? So you don't know what you don't know. You might have a whole bunch of processes in place to better understand how, where sensitive data lies, where PII data lies, where PHI data lies, corporate sensitive information. But at the end of the day, usually there will be holes, right? You need fallbacks. And, in Snowflake, we can provide, tagging and classifying capability, right? Which has really emerged in the last couple of years through data catalogs as well. As how do we tag with metadata to say, who owns this? What type of sensitivity does this data have? And how we can utilize those tags to better drive governance implementation down the process. And then sort of thirdly, security is inherently rigid and governance inherently rigid, but doesn't have to necessarily block users, right? You can still have strong controls in place, but you don't want to do in such a way that destroys innovation from an analyst perspective, right? Or limits it, allows them still to experiment and sandbox. And that's perfectly doable inside Snowflake through zero copy clones and our role-based access control model. But also you want a model that's not too complex, but it's simple in sort of the rest, the ingredients. That's especially in the role-based access control in Snowflake. It's consistent, it's easy to monitor, and sort of making sure you're not having to deal with potentially a lot of organizations have multiple data platforms serving different functions. You've got different security models in each platform, and then you're having to sort of stitch all those security models together in an overarching one. Whereas at Snowflake, we can bring workloads together in one and unify them under one security and governance layer. So if we look at the Snowflake governance capabilities, so when we talked about tagging, so knowing where your data is, the data is complex, it's everywhere. We want to know where the sensitive stuff lies. We're working towards with classification capability, so we can automatically go in, and I'll touch on the next slide on how you apply it, but you can start to automatically tag. So Snowflake can look at your data and go, there's a name here, there's an address, email address, IP, and so forth. Start to tag that. You also have the object tagging framework, which lets you manually add tags to where you desire, like to say, okay, who owns this database? Who owns this table? Who owns this compute layer? It could be one domain or line of business, another domain, line of business. Gives you a good breakdown into who's using what, how many resources they've got deployed in the data platform, and then also cost control over that, right? It really just opens up that transparency as to who's driving the cost of the platform, what value is coming out of it, right? And transparency in these data platforms has traditionally been a big issue in terms of how to derive value of the cost going in, right? And sort of moving to protect your data, right? Once you've tagged it, in Snowflake, we already do column level masking, row level security. That's already done. We can link with external tokenization platforms. The idea is next we can move to automatic anonymization, right? So based on the auto tagging, we can say, we found a date of birth, right? Since that's a potential identifying attribute for an individual, and we can mask it in such a way that's analytically preserving. So you don't necessarily destroy the data and just hash it or redact it. You can still allow it in an anonymized way that's privacy regulation compliant to still run analytics and give value to data science and analytics teams on top. And sort of lastly, we recently introduced access history to know who's accessed your data. So you could say, these key tables, who has accessed it in the last 7 days? How many times have they accessed it? So you can use to verify if your security model is working or if you've got holes in there. So you can start to create dashboards around that to see, how is this working in practice? Also, who's accessing the most sensitive data? On the flip side, also helps you understand who's not accessing data, which tables are not being used, right? You might have spent a month integrating a new data source for a business requirement, and then suddenly you find barely anyone's using that data. You can then dive in, why? What's actually wrong? Did we get the requirements wrong? and so forth. So it really gives you insights into the behavior and the underlying system. And so this sort of slide gives you an idea of how we can then start to bring, so it's not enough to just offer these features and say, you know, here's the documentation, this is how you use it, but here's how we can actually embed it in real life, right? So here's how we can bring governance policies to the data engineering teams in a language that they speak, right, and understand. So, you know, step one, we can read data, like I said, structured, semi-structured, unstructured. We can then classify, right? So in our data pipelines, we can embed this logic and these functions to say, well, as this data gets ingested or read, for instance, on the data, you know, it might be a data lake in Snowflake or an external data lake, we can tag that data for sensitivity. We can establish ownership through tagging as well from domains and lines of business. Once we have that metadata, the key metadata, we're able then to start to say, well, based on that metadata, we can protect it. So we can create anonymized views. We can do column level masking, row level filtering, etc. And that's all. And we can start to automate that within the data pipelines and Snowflake security model, right? We can then still transform that data, right? Like we said, with anonymization, we don't necessarily have to destroy the analytical value of the data. We can still be compliant with our privacy requirements. And you can do that in a performant, scalable, battle-hardened engine in Snowflake through the transformation layer. And then you can freely start to serve this out to BI visualization, data science, data applications, data sharing with your partners, and so forth, right? And then at the end of it, once you've got all this activity going through the system and you've got enough volume happening, you start to analyze that behavior through access patterns like we talked about, right? So all of this can be embedded as sort of ingredients in data pipelines. It's very easy to action and sort of it brings a technical implementation to the sort of desired state that the governance policies across an organization are want to achieve. And, you know, just to sort of end this slide as well, all of this sits on top of cross-cloud data sharing as well. So like when we talk about serving analytics, you can still serve anonymized data, provided you're meeting your privacy requirements. To your partners, they can serve anonymized data to you to better understand, to join to your data sets, so you better understand your customer, your audience, and so forth, whichever entity you're looking at. And so, you know, how can, just at a quick look, how can we securely share data outside of an organization? We've, you know, pioneered a concept called the data clean room. And so the idea is, you know, party A, party B can come together through double blind secure joins, restricted queries. So the idea is they can still see the overlap. You know, for instance, a retailer might be talking to a media broadcaster around, okay, I want to measure how I'm impacting my audience through advertising on video on demand, on traditional TV, for instance, right? And they want to get a better view directly of how they're doing, how that's working. So they can use their anonymized audience data, link it with the anonymized audience data from the other party and start to understand. And likewise, the media broadcaster also gets insight from the retailer. So the whole idea is it's win-win for both organizations, right? Allows you to answer questions of data while preventing drill down to PII and, you know, not, you know, basically preventing any breaches in high-level governance policy. And it's still, this is not just for small data sets or anything particular. You're able to enable compute against massive data sets, right? So, you know, we could be doing data clean rooms on millions of rows, billions of rows, more than that, right? So you're not restricted by scale either. And so in summary, just to sort of cover everything off, why Snowflake? And so basically in this session, you know, we demonstrated, you know, with Snowflake, you're able to cover those requirements around data is everywhere. It's complex. Security and governance are rigid, right? And these are sort of the requirements. There's obviously more to these, but these are what we see customers tell us, right? As a base level, we need column and row level security. It needs to be a mature implementation, right? You know, but before we even do that, we need to know, well, where is all the sensitive data? Sometimes you know, sometimes you don't know. So especially when you're onboarding new systems, so we can classify and tag data. We then automatically anonymize that data, like we said, preserving analytical value. We can serve and share those data sets, whether internally, externally, across clouds, across regions in the same cloud, it doesn't really matter, which really sort of breaks down a lot of the traditional technological barriers to this type of data sharing. Being able to understand data access patterns, and establish deep audit trails. So what are the most used attributes? Which sensitive attributes are accessed and how often? which sensitive attributes aren't accessed for whatever reason, so forth. With the clean room approach, you're also able to, like we talked in the previous slide, better understand your problem domain, right? I've got a view of my audience, an organization in my ecosystem has a potential slice of my audience. I want to be able to get that overlap to improve my analytics, my business outcomes. Likewise, they have similar outcomes. We're able to engage securely through a clean room sharing approach. And lastly, Snowflake is not an island where all of this is just black box and, just sort of locked in. All this metadata that, from tags and everything, it's freely queryable and exportable, right? And the idea is this will integrate with your enterprise data catalogs and part of sort of a wider governance ecosystem. So that's pretty much it. Thank you, everyone. Thanks for your time. I hope you enjoyed the session.